All right, we're going to get started. So welcome and thanks for coming. My name is Martin Zinnes, and this is Andrew Bruno. We're from the University at Buffalo Center for Computational Research. And so today we're going to talk about how we integrated OpenStack basically into our identity management infrastructure that we use at the center. So just give you kind of a quick background of where we come from and who we are. So we're from the University of Buffalo Center for Computational Research. If you're not familiar with Buffalo, it's in New York State, not too far from Niagara Falls, about a 2-hour drive from Toronto. We're an academic supercomputing facility where we support the faculty research at the university and provide a variety of HPC resources for our users. We support a variety of academic research projects that you'd see at any research university, as well as some internal projects that we support. Just going to talk about one of those just quickly is XDMod. It deals with HPC monitoring and auditing. The only reason I mention it is because it's one of the services that we run at the center that integrates with our central authentication system, and we just want to add OpenStack to that same system as well. So as I said, we have a wide variety of resources we provide for our users, so academic clusters, various storage solutions, as well as a OpenStack installation that we use for our own internal use, but also for faculty users where they need different resources from the traditional HPC offerings. And so how we got started with OpenStack was basically through what's called the Aristotle Project. It is a grant that we received from the National Science Foundation to collaborate with Cornell University and UC Santa Barbara, basically to develop a subscription-based private research cloud that we can use and federate between the different institutions. So Aristotle is the whole federation, and then when I talk about Lake Effect is the actual cloud that sits in Buffalo. And so just give you a quick overall overview of what we're trying to accomplish. So the challenge here is integrating OpenStack with CCR's existing central authentication infrastructure. And we're going to talk about what that infrastructure is and how we develop solutions to integrate with it. And so we accomplished this, and in the end, really the accomplishment was single sign-on for Horizon, as well as API key access to the command line interface. And along the way, we wrote a couple pieces of software, Mochi, that Andrew's going to talk about, and then a Keystone plugin that interfaces with Mochi and handles the authentication pieces. And so now Andrew's going to talk about the backend infrastructure.
Okay, thanks, Martins. Okay, so like Martins mentioned in the beginning, one of the challenges that we had when we initially installed OpenStack was integrating it in with our central authentication infrastructure. So I just wanted to give a quick kind of overview of what that looks like. And some of the main motivations that we had for doing this was we wanted our users to have a similar experience logging into OpenStack as they do with our existing web applications that we support. So this gives you a quick overview of what our central authentication infrastructure looks like. So we run a very heterogeneous environment at CCR. So we have traditional HPC clusters where our users are logging in via SSH to Linux clusters. And we also have several web applications that we support, anything from web portals where users can submit HPC jobs to, like Martin's mentioned, XDMod, where they can kind of see their usage and their job overviews. And also, we have a couple of web applications like internally for managing allocations that they log into as well. And all this is backed by our identity provider, which is FreeIPA. We'll talk a little bit about that. And in front of FreeIPA, we have written an identity management portal called Mochi, which kind of handles the self-service user account management features. And also we have a hook into OpenID and OAuth to provide single sign-on in our web applications. So how do we kind of plug OpenStack into this infrastructure? So OpenStack actually supports this out of the box. It's called Federated Keystone Identity, and it allows you to integrate your organization's identity provider and allow your users to use their kind of existing credentials to log into OpenStack. So one of the first kind of challenges we hit was just kind of wrapping our heads around all the the various terminologies that go into this federated login. It's kind of daunting at first. So what we tried to do for this talk is kind of distill it down into 3 components here. it's a little, federated identity goes into a little bit more than this, but for the purposes of this talk, we're kind of going to focus on these three components: service providers, federation protocol, and identity providers. So on a service provider, that's your typical web application that you want to kind of integrate into your single sign-on system. So obviously, we're going to be talking about OpenStack here, but some other ones that we run at CCR are XDMod and Open On Demand, which is kind of a web portal for HPC jobs. But it can be really any web application that you want to plug in. The federation protocol is kind of the language that is spoken between your service providers and your identity providers. So things like SAML, OpenID Connect, and OAuth. And then on the identity providers, that's where your user credentials are actually stored. So LDAP, FreeIPA, Active Directory. So for this talk, we're going to be focusing on the technologies we chose to kind of integrate into CCR's infrastructure, which are FreeIPA and OpenID Connect. And kind of the rest of this talk is kind of dedicated to kind of how we actually set this up and some of the challenges we hit along the way. So this is what our technology stack looks like. So for the service provider, obviously it's OpenStack, but really what you're configuring there is a Apache module called modauth OpenIDC. So that's kind of the module that actually speaks OAuth and OpenID and allows the federated web logins. For the federation protocol, we're using OpenID, and the actual OpenID implementation we're using is a project called Hydra. And we'll talk a little bit about that. And then on the identity provider side, we're using FreeIPA, and we have in front of that a in-house built identity management portal that we call Mochi. So first, we're going to talk a little bit about the identity provider. So we run FreeIPA. For those of you not familiar, it's an open source identity management solution. So it's actually a really awesome project. It's a collection of a big collection of existing open source tools. So they kind of package Kerberos, Bind, DNS, 389 directory server, NTP, into this kind of nice package, nice command line utility, and web interface for managing all these services. So I don't know if you've ever tried to manage these kind of on your own. It's pretty daunting. So they do a great job of, they have commands for provisioning identity management servers, and also on the client side, they have a really nice tool for provisioning your clients. So we use this quite extensively. So on the client side, we run Linux, and the way FreeIPA, or the Linux clients speak to the FreeIPA servers is through SSSD. So we use it for full full identity lifecycle management. So all our user accounts are stored in FreeIPA, Unix groups, hosts, we manage all our services, security policy management, so we have host-based access control, all centralized, centralized sudo. We also use FreeIPA for two-factor authentication as well, and it runs our entire DNS infrastructure. Some of the things that were not built into FreeIPA were things like self-service user account management features. So if a user forgets their password, we kind of wanted the ability for them to kind of click a link, maybe get some kind of token that allows them to reset their password, through some challenge like a security question or something. Also, onboarding users, when we create our user accounts, we want them to kind of self-service set up their password. So some of that wasn't built in. And also there's no, FreeIPA itself does not come with an open identity provider. So that kind of led us to build our kind of own solution to kind of fill in those few gaps. And that's something that we call Mochi. So it's a self-service user account management portal. It's really lightweight, so it just sits in front of FreeIPA. It's pretty easy to install. There's no LDAP schema changes or anything you have to make in FreeIPA. And it just kind of provides some of the features that FreeIPA already supports, but allows the user to kind of self-service those. And we're also able to, when we started deploying OpenStack, kind of solve some of the command line authentication challenges that we hit by adding in a little hook for this API key support for the command line, which we'll talk about in a little bit. I just wanted to mention some similar projects. So there's a project called Ipsilon that actually is a OpenID provider. They also support SAML, OAuth, and I think Persona. So that's a really great project that we're going to be looking at. And also Keycloak. So these are some similar things. So this is kind of a quick shot of what the dashboard looks like when a user logs in. They can see their account information. They can change their password. They can manage some public SSH keys, two-factor authentication. Okay, so next up we're going to talk about the Federation Protocol. So for that we chose OpenID, and we're not going to get into too much about OAuth and OpenID, the technical aspects of it, but basically OpenID is a very simple simple identity layer on top of OAuth. And its really main feature is it supports simple JSON-based identity tokens. So this allows you to assert the identity of a user through these tokens, and it also allows us to include additional information about the user embedded in that token. And for the purposes of OpenStack, we're actually embedding some information like the name, the email, and the groups that the user belongs to. And that allows us to, when they log into the Horizon dashboard, kind of make some decisions on what projects to put them in and whether or not to allow them access. So for that, we're using an OpenID implementation called Hydra. So this is an open source project. And some of the things that we really like about Hydra is it's really easy to install. It ships as a single binary. It's written in Go. It has a lot of great features in terms of security policy management and things like that. And one of the nice things, it doesn't make any assumptions about what your identity provider is, or it doesn't come out of the box with authenticating users. You have to kind of implement on your own. And what was nice about that is it allowed us to use our existing authentication infrastructure and our existing login flow, but just slap OpenID on top of that. So that was kind of nice. So this gives you a quick example that you manage all your OAuth 2 clients through the command line. So here we can quickly create an OAuth 2 client for OpenStack that we can configure in the Horizon mod auth OpenIDC configuration. So one of the things that Hydra, or in order to integrate with Hydra, you have to implement this thing called a consent flow. And that allows you to connect Hydra with your identity provider. And essentially, it's a very simple HTTP-based redirect flow for authenticating users. And Mochi, which is our identity management dashboard that we wrote, is kind of the Hydra consent app that sits in front of FreeIPA. So to kind of tie all these things together, I just wanted to go through real quick what that consent flow looks like in terms of this HTTP redirect flow. So this is kind of all the stuff that happens when a user, for example, is going to log into the Horizon dashboard. So the first thing is, the user opens up their browser, they're going to request the Horizon dashboard. They're going to hit mod auth OpenIDC there, and it's going to say, I don't know who you are, so we're going to redirect you to our OpenID provider, which is Hydra. So Hydra is going to, OpenStack's also going to perform what's called this OpenID Connect request. And Hydra is going to say, I don't know who you are, so I'm going to redirect you over to its registered consent app, which happens to be our identity management portal called Mochi. So here, this portal is going to handle all the user authentication. So users are going to log in, present their username and password. There's two-factor authentication. Mochi is going to validate that all against FreeIPA. And when everything checks out, the user is going to be presented with something called the consent. And that kind of looks like this. So basically what's happening here is, you've probably seen this before, logging into other similar systems. There's an application that wants to access your profile on your behalf. Do you give consent? So the user can approve or deny here. So once everything is all successful and the users approve the request, they get redirected back to Hydra. So Mochi is going to kind of sign that consent form and send it back to Hydra. Hydra is going to validate this consent, make sure it looks all okay, redirect it back to OpenStack. Now OpenStack can then consume the ID token that was sent back to it, make sure it all looks good, and then they can actually grant or deny access based on the information in that OpenID ID token. So what that looks like is a very simple, JSON ID token again. And in here, like lines 4 through 8 there is really the sweet spot where we kind of can put our own custom information in there. And we actually include all the FreeIPA Unix groups in this ID token so that right away we can kind of do access control based on that to the Horizon dashboard. So now we're going to talk a little bit about the service provider. So Martin is going to kind of go over how we actually configured OpenStack and Horizon to kind of make all this happen.
Thanks, Andrew. So now basically going to talk about taking the things that Andrew talked about and map them onto what's happening on the OpenStack side as that process goes on. So the first thing we're going to talk about is what happens when you log into Horizon. So you try to log into Horizon, you're presented with the standard login page. If you have local credentials, type in your username, password, domain, things like that. With the federated login, you're presented with a drop-down now where we can choose the CCR OpenID Connect provider. And you then are presented with that page, and you click Connect. And the way that this happens is through changes to your local settings file for Horizon, where you say basically, I'm not sure if my pointer's up here. So we're adding this new provider, and this is the protocol that you're using. This is the provider that we're going to link to that protocol, and I'll show you later on kind of the OpenStack commands to create these, but the important part here pretty much is just to say that this is a new single sign-on mapping that we're presenting the user with. And so you click the Connect button, and you're presented with a login page. And just going to go through, when Andrew's going through those steps 1 through 6 before, just by clicking that button, you've done steps 1, 2, and 3. So pretty much you're saying, I want to log into Horizon. You're redirected to Hydra with the OpenID Connect request. And then that's redirecting you to Mochi to actually log in. So type in your username. You're presented with the complete the login page. Type in your password. In this case, we've activated two-factor authentication. So pull out your mobile device, type in your code. It's up to you how you do that. And then again, presented with a consent page. So you're giving OpenStack consent to user credentials to log into Horizon. And you approve that, and then you're logged into to Horizon. Just one last thing you need to do is then give this address as your trusted dashboard in your Keystone configuration, so the Keystone only sends the token data back to trusted servers. And then I'll try to go through some of the configuration, but not touch on every single detail. But as Andrew said, pretty much the thing that handles all the authentication here is the modauth OpenIDC plugin. And all the configuration parameters here match the different settings that you set up in your Hydra provider. So you're setting your client ID to OpenStack. The client secret that was set when you created that Hydra endpoint, you put in here. And then also you set a location that's going to be protected by OpenID Connect. So basically we're saying anything that hits this location will be protected by OpenID Connect and requires a valid claim set up for the OpenStack audience. And then the final thing here is that redirect URI that was set up for Horizon, or that was set up for Hydra, basically is a vanity URL. It's just something to stick in there for Hydra to match the redirect, but it's not actually anything that serves any kind of content. But it needs to be under the location that you're protecting. And just showing you that matches, the callback we set over here is the exact same redirect that we set here, and all these other different scopes and things like that match where this secret here is what you would put in the configuration file. So you log in, all is great, but what we also want to do is match users to the appropriate groups they need to be in. So as Andrew showed you that JSON Web Token, we pass along the groups from the backend infrastructure, and we want to say, a certain user may be part of different groups, may be part of different projects, and we want them to be able to choose that inside of OpenStack. And the only thing we want to do is we want to prevent access to users that shouldn't have access to the system. So we've got thousands of users, but only 100 or so actually should have access to the system. So we want to prevent the users that don't have access from logging in. So the next thing I'll talk about is how we implemented those ACLs. So basically, we want to whitelist certain Unix groups specifically for OpenStack. So I mentioned this is a federated project. So basically, we have local users that we stick them in the lake effect dash whatever group. And then we have federated users from the other sites that are in the Aristotle whatever group. And we want to limit access only to those groups. And so this allows us centralized user and group management while still maintaining whatever fine-grained control we want to. And then we just create basically placeholder groups in Keystone for these users to land into. And I'll just go through fairly quickly the actual OpenStack commands that generated this, but it's all fairly standard stuff that you can find in the documentation. So create a new identity provider where the remote ID matches what your authentication infrastructure has. We're calling this CCR. And then basically the heart of this is a mapping file. So it's a JSON file that tells OpenStack how to create a mapping between your central authentication users and what groups and projects they land in OpenStack. And so I'll show you kind of what that looks like. So basically what we're saying is, on the remote side, we have a bunch of claims that come back in that JSON web token. And so in this case, the first one is basically the username, and we map that to the user's username up here with a 0 identifier. And we're saying that anybody that comes in gets put in the domain lake effect that we've created for this project. And then the second claim that comes in that we're pulling out is your groups. And so we're saying, let's create a group with that name, again, in that domain lake effect. And you can see that matches, the groups are pulled from here, the username is pulled from here, and it just does the mapping from the web token. And then finally, we link this mapping that we've created here to the identity provider that we create up here. And then we create a domain called lake effect. We create, for each project that we want to be able to log in, we create that project in the domain, create a group in that project, and then we assign a role of user to that group so that everybody that comes in and lands in that group already has the user role assigned to them. We don't need to do any user management locally inside of OpenStack. And then the last thing I'm going to talk about, we talked about we want to do this ACL management. So what we're saying here is here's a whitelist of groups that we want to allow in. We want to use a regex for that. Currently, the Keystone authentication doesn't allow that, so we have a small local patch that allows you to do regexes with whitelists that we'll work on getting that pushed upstream, because we think it's very useful. And then the final thing I'm going to talk about basically is command line single sign-on. So we've got a lot of users who use the command line, whether it's for batch processes or rapid testing, or they've got existing scripts that they've used for quickly bringing up and down VMs and different things in their project. And so what we really want to do is use the same infrastructure for the command line tools. Don't want to have any separate user accounts in OpenStack, because managing that is kind of a nightmare. And kind of one of our own requirements was we wanted no passwords in the OpenRC file. So as I mentioned, we've got all these other web portals and services and HPC resources that are all managed by the same infrastructure. If your password is compromised, all those services are compromised. And so we don't want to have to deal with that. Whatever the authentication infrastructure is for OpenStack, if that gets compromised, all you're really compromising is this portion of it. And so what we really want to do is leverage OpenIDC authorization code flow. And so that's what I'm going to talk about, how we implemented that. So we created a new auth plugin. Keystone has this nice implementation in place for creating new authorization plugins. And so this basically interfaces with the Mochi infrastructure that we have to authenticate you to OpenStack. And basically the high-level flow is creating an API key in Mochi. So if you're familiar with creating one for GitHub or anything else, you create an API key that you can use for different services. This plugin exchanges that API key for an OpenID Connect authorization code. And there's already a plugin in Keystone that knows how to exchange that authorization code for an access token or ID token. And so we've extended this v3 OIDC auth code plugin to understand how to do that first step of converting the API key to an authorization code. So what a user does is creates an API key in Mochi. It's scoped only for OpenStack CLI. No other services are exposed. Can be revoked and regenerated if it's compromised. So if there's any issue, right from within the portal, the user can deactivate it. And basically what this means is that long-term consent is given at key creation time. So you're creating this API token, and you're consenting that it can be used until revocation for this service. And basically the API key is used to auto-complete the consent flow in Mochi. So whereas through the web logon, you're giving your consent explicitly through that web page, the API key is used to do that automatically for you. And then just as one more thing for the users, we modified the OpenRC template that they download from Horizon. So all this is kind of already baked in there. All they need to do is put in their API key. So this is what the page looks like. You go to the API key page and click on the Create API Key. And it asks you to confirm that, yes, I want to do this. And this is what you're going to open up by doing so. It's presented to you as painted on the web page, so you copy and paste that into your configuration file, and then tells you, the API key was created, when it was last accessed, and gives you the option to delete it, and so on and so forth. And so basically what this looks like to use this in the OpenRC file is, the top stuff is kind of standard OpenRC configuration, but at the bottom, what we're saying is, put in your long API key, use our new plugin, and then you fill in your identity provider, the protocol, the endpoint that we configured previously, your client ID, and the redirect URI. And so what we found was, this worked great, but pretty much every time you run an OpenStack command, it's going to hit the central authentication infrastructure. So if you have users doing high throughput commands, or maybe you at certain points have a high demand on your infrastructure, it may cause an unacceptable delay. Not really too long, but just a couple seconds. But if you're running thousands of commands over and over again, it could cause an issue. So we provide another way for the users basically to cache a Keystone token. So everything else stays the same, except that instead of running whatever command you want with those credentials, inside the OpenRC file, we pre-cache and pre-grab a Keystone token for you, and then reset the authentication type to Keystone. So that then that token is cached for you for an hour or whatever you set your Keystone expiration time to, and then every time you run an OpenStack command after that, you don't have to go grab a new token. The downside there is then that whenever that token expires, you pretty much have to resource your OpenRC file, but that's kind of acceptable for us based on what our users are doing. And so to make that all work, basically we protect another endpoint. So we're protecting the endpoint that generates the Keystone tokens. And really what we're doing here is basically just protecting it with OAuth. Because all we want to do is the token that comes in, we want to confirm that actually is a real signed OAuth token, and inside of it has a claim that matches the endpoint that we set up in Hydra. And so if you're familiar with ModAuth OpenIDC, just does local introspection to validate the token's valid, and passes that on to Keystone with all the group and user information.
Okay, so just to recap kind of what we went over today. So we've kind of achieved federated single sign-on to Horizon, which was really nice because our users are either used to logging into our identity management portal. All our web apps kind of use that for logging in. So it's really nice, especially we just recently rolled out two-factor authentication. So not to have to duplicate that somewhere else is really nice. And also so after we did that, we kind of hit the problem of, well, how are the users going to actually use the command line? Because we have this nice two-factor authentication protection on the website, but how are we going to handle that on the command line? So we were kind of able to get the CLI working with the same credentials, and the user experience wasn't hindered too much. And also, we obviously didn't want to have users storing their username and passwords around, because there are some solutions that you can kind of work with that require that. But in the case of single sign-on and the federated logins, you don't want your users potentially getting that password compromised, because then it compromises a whole slew of things. So we were able to kind of create our Mochi identity management portal to create these idea of API keys, which can support other applications as well. So some of the future work that we're looking at is, our work with the Aristotle Cloud Federation is really about trying to get universities really all over the country to kind of build a cloud and kind of create this nice federation of academic clouds. And we're going to need to support these logins outside of our university, potentially from other universities across the country. So one of the things we're thinking about is probably leveraging Globus, because they have a nice framework for doing that, and kind of integrating their single sign-on OpenID into ours as well, and also possibly hitting the same issue with the command line and kind of solving that with maybe a Globus provider command line plugin. And also, so Hydra is a really awesome project, and it's kind of evolving really quickly. So they haven't actually released in a 1.0 release, so it's still kind of, the APIs are kind of in flux. So we're currently running 0.912, which is a little old at this point, so we're going to try to upgrade as soon as they get out to a solid 1.0 release. We'll upgrade that and kind of get that going. Thanks for coming. So my name's Andrew, and my colleague is Martins, and we're from the University of Buffalo again. And so we wrote some software. Feel free to check it out. We're open to comments and suggestions, and if you're running FreeIPA, it's definitely something to look at. Thanks a lot for coming, and hope you enjoy the rest of the conference. Any questions? Yes?
Yeah, just a couple quick ones. So beyond the small patch that you mentioned around regex matching and your config and the Mochi stuff that you got here at GitHub, were there other code modifications, or was the rest of it like bespoke Apache configuration?
No, I think outside of the patch we did for ACLs,
Yeah.
We didn't really change anything in OpenStack. This was.
Patches available too, the ACL patch? Or?
Yeah, we can put it up somewhere. It's I don't know, a dozen lines of code. It's pretty straightforward.
Yeah, we're trying to get it upstream. That the issue really is just working out the legal aspects that OpenStack requires with the university and all that. So.
Yeah, so we can make it available that anybody wants it, but I don't know
Yeah.
if it'll ever get submitted. So.
And then, so thank you. I'm interested in checking out your code. The second question I have, could you back up to the caching model that you set up really quick?
Sure.
There was one little thing that I missed on here. So how do you get around the problem then of the token living inside of an environment variable? If somebody were to get access to that, they're going to be able to introspect it. Is that a...
Right. So.
Yeah, I mean, for us, it was, I guess, acceptable level of risk for our environment. It was, we started using OpenStack about 6 months ago, and so we're trying to kind of figure out where our paranoia versus our ease of use is. And so in this case, it was the ease of use kind of, I think, is a little more important than that for us right now, but it's something we're continually evaluating is, kind of what we want to provide and what we want to make available for the users at a certain level. There was some thought of, well, when you want to use this every time, you got to generate a new code, you got to go to a web page and do that and copy and paste, and our users weren't going to do that. So we're kind of trying to figure out what our acceptable level of risk is.
And add to that, a lot of the users who are using the command, they're using it from their laptop, not necessarily like a shared server. So that might be a little mitigated by that because they're on their own machine. So,
Cool. Yeah, and I guess it's pluggable anyway, so we came up with a better cache.
Right.
Exactly. Yep.
Thank you.
Yep.
By the way, what type of Keystone tokens do you use right now? Not currents?
Yeah.
Not currents.
Yeah.
So, okay. That's probably why caching is an interesting thing to do.
Yep.
Yep.
How does the workflow of creating a user group look like for you? And do you use the Keystone auto provisioning feature?
Well, so I'll speak a little bit. So we have a kind of a homegrown system for creating users that kind of get our users into FreeIPA. They go through kind of a self-activation setup, and then they're put into different Unix groups that allow them access into OpenStack. Do you have anything to add to that?
No, then yeah. So I mean, basically, if I go back to wherever that. Yeah. So here. So yeah. I mean, the users are auto provisioned based on the name that came in the sub here, and so the user is just automatically created. So if you look in the database, there'll be a federated user with that name.
They're like ephemeral users. They're auto created once they log in, and all we have to do is create a group. We don't have to keep creating user accounts actually in OpenStack. Those happen automatically, which is nice. So we don't have to sit there and every time we create an account in our existing system, then go back to OpenStack. We kind of wanted to avoid that because it adds a lot of overhead with creating accounts.
Oh, back there.
On the Mochi side of things, have you guys considered having a Kerberos pass through so you can, if you had a ticket with IPA already, when you hit Mochi's login page after you try to log into OpenStack, it would automatically pull your Kerberos ticket, authorize you, and there wouldn't even be a password prompt?
Yeah, that's actually a really good idea. That's definitely something we could look into supporting. Right now, we don't have any users who really could get that Kerberos ticket, on their desktop to actually use it. It's usually a little harder to train the user on how to do that. But yeah, that'd be a pretty cool feature for sure.
So I have a similar setup. I'm using OpenID for my provider. So I'm trying to map this all out.
Yeah.
But we do have the ability for users to use Kerberos tokens, which if they're using our supported Linux desktop environment, they can have
Oh, cool. Okay.
to authenticate through the web page. We don't I'm trying to figure out how to make an existing OpenStack that stick together with a new
Ah,
but you can definitely do that.
cool.
Yeah, being an academic environment, we have users that have all different laptops and desktops and OSs and things like that, so we can't really control what they're running at their desk.
I can't do that.
Sure. All right, well, thank you very much. If there's no
Yeah,
other
thanks a lot.